Hi there. This is Unit 5, Lesson 7 video. This is the second last lesson that you guys are going to have to learn before attempting the final assignment. So you'll have Lesson 7 today, and Lesson 7 today is all about slope and X and Y intercepts. Okay, so you may have heard of slope before. Under definitions there, I also wrote in brackets, slope is also known as rate of change. Okay, so if in your textbook it ever says determine the rate of change, really it's just asking you to determine the slope. Now the slope of something is essentially how steep it is. Okay, so every graph, like every line down here that you see, has a different slope. Some of them are pointing upward, some of them are totally flat, some of them are on a decline. They all have different slopes. So to determine the slope of a given line, we are going to use the following fraction. Simply put, rise over run. Okay, so what we're going to do is we're going to find two dots on the graph and we're going to rise up and run over to join the other point. That might sound a little bit weird, but it'll totally make sense once we do an example. Okay, next is the x-intercept, also known as the horizontal intercept, and this is defined as where the graph crosses the x-axis. Okay, so whoops, so the graph is going to kind of cut across the x and y axis. So if I ask you for the x-intercept or the horizontal intercept, I want to know where does it cross the x-axis at. And then for the y-intercept, whoopsies, it's where the graph crosses the y-axis. Okay, and whenever I ask you for the intercepts, I want you to always write them in the form of a coordinate point. So when we're talking about graphing, that's a coordinate point. So I'm going to give you, for example, something like this. If I give you that and I want you to plot that, you find 4 on the x-axis and then you would move up to 3 on the y-axis. Okay, and that's a point on the graph. So whenever I ask you for the intercepts, you have to write them in the form of a point. Okay, all right. So for each graph below, determine the slope, the x-intercept, the y-intercept, and then we're also going to determine the domain and range. That was from last lesson, lesson 6, and we're going to do domain and range again today because I know some students were struggling with it, so we're just going to do some more practice. All right. So the slope, first of all, like I said, you have to choose 2 points on the graph. On this graph right here, we can see there's 1, 2, 3, 4, 5 points for us to choose from. You can choose any 2 you want. They can be the ones furthest apart. They can be close together. It does not matter. I am going to choose this one right here and this one right here. Now what I do is to figure out the slope is I want to travel from one point to the next by rising and running. So to get from the point down here to the point up there, I'd have to rise 1, 2, 3, 4, 5, 6. So I'm going up 6. And then once I get there, I'd have to run or go to the right 1, 2. So I went to the right 2. So my rise is 6. My run is 2. So if I'm writing down my answer here, my slope is rise over run, which is actually 3. So this has a slope of 3 or an incline of 3. All right, next we're going to find the x-intercept. Okay, so I told you the x-intercept is always in the form of a point. To find the x-intercept, I look at where does the graph cross the x-axis. So here's the x-axis right here, as we know. So we want to see where does the line touch the x-axis, and it's right about there. So it's not on an exact tick. It's kind of partway through between 0 and -1. It's between those 2 ticks there. So you're just going to estimate if this is 0 right here and this is -1. I would say that's about negative 0.7 or so. But you're estimating, whoa, what was that? I'm going to erase this to make it a bit bigger. But you're estimating, so if you have like negative 0.75 or something, that's fine. But it crosses the x-axis at negative 0.7. And then my y value there, because it's on the x-axis, I know y is 0. All right, next we're going to do the same thing, but with y-intercept. So again, it's the form of a point, and I'm looking for where it crosses the y-axis at. So here's the y-axis right here. Where does the line cross the y-axis? The blue line right there. And whoops, and that is at the y value of exactly 2. So my y value is 2 now. And then whenever you cross the y-axis, you know your x is 0. So for x-intercept, you find where it crosses the x-axis at, and then your other number will always be 0. Similarly, when you find the y-intercept, you find where it crosses the y-axis at, and your other number will always be 0. All right, I'm going to do domain and range down here. So domain, if you remember from yesterday, is how far left and how far right does this graph go? Well, this point right here is the furthest left point of the graph, and that's at a value of negative 2 for x. And then my furthest right point is up here and doesn't go past that. That's at a value of positive 2. You write those two numbers down. X is in the middle. You always put your Pac-Mans in that direction, and then each of them has a line underneath because the circles are colored in. Range, now it's how high, how low. So my lowest point is right here as well, and that's at a point of negative 4 on the y-axis. And then how high it goes is way up here, and that's at a value of 8 on the y-axis. Your Pac-Mans always go in this direction, and they each have a line underneath. So there you go. We just found 5 pieces of information about one graph. All right, next here, slope. Rise over run. So for rise over run, you pick 2 points, but I don't have points actually drawn in for you here. So you have to find 2 points that cross at exact values. So what I mean is right here, I see that it crosses at negative 3. That's an exact value. And right here, it crosses at 6. That's an exact value. Those are 2 points on the graph that I can jump between. So if I start here, I know I'm starting on the x-axis, which is 0, and I move up 1, 2, 3, 4, 5, 6, and I'm stopping at 6 because now I have to start running over. So I went up 6, and then I'm hopping 1, 2, 3 to the right. So I looked down here, so I saw that I was over top of the negative 3, and so to get over to this point right here, I know I'd have to go from negative 3 to negative 2 to negative 1, and then I'm on the line at 0. So I went to the right 3. So my slope is rise over run, 6 over 3, which is actually 2. Always reduce your fractions, please. All right, there was slope. Next, x-intercept. Where does it cross the y-axis? Or sorry, the y-axis, the x-axis at? So the x-intercept, it crosses the x-axis at negative 3, and my y is 0. Y-intercept, it crosses my y-axis at 6, so my y is the 6 and the x is 0. Domain, okay. Now, we see right here, that's the furthest left point, that's at negative 4. And then we see right here, that's my furthest right point, and that's on top of positive 4 for the x values. And we have Pac-Mans in that direction with lines underneath. Okay, now range is how high, how low. So the lowest my graph goes is right here again, and that's at negative 2 on the x-axis, or y-axis, sorry. And the highest it goes, its max is right there, which is 14. Pac-Mans always go in that direction. Groovy, done. Okay, so slope, rise over run again. So here I give you points. You can travel between any points that you want, okay? I'm going to travel between these two right here. Now, I need you to pay attention right now. If we're traveling between these 2 points, you have options. So I'm actually going to zoom in here so it's a little bit bigger. You have options because it doesn't matter where you start. If you want this to be your starting point, what you would do is you'd have to go down 2, right, over 1. Now, when you go down, that's going to be negative. When we rise, we're going up, and that's positive. That seems natural. But when we're going down, we're doing something opposite. We're actually going in the opposite direction. Okay, so we're actually going to put a negative in front of that too, because we're going down. But when we're going to the right is positive, so it's positive 1. So my slope then would be rise, which is actually negative 2 over 1. Now you have another option, depending on where you start. If you want to start here, to get to the next point, you would rise 2. So we're going up, so that's positive 2, right? But now we're going to the left. And when you run to the left, that's negative. All right. So whenever you're going down or to the left, you're gonna put a negative in front of that number. So if we use these two numbers to create our slope, it's still rise over run. So my rise is positive 2, but my run is now the negative 1. In either scenario, both of these slopes are the same. Oh my God. Because this one here equals negative 2. And this one here technically also equals negative 2. I'm just reducing. So regardless, the slope is negative 2 no matter how you cut it. All right. X-intercept, where it crosses the x-axis, is exactly at 2. And then the y is 0. That's that point right there. Where it crosses the y-axis, or my y-intercept, is at 4. So my y value is 4, x is 0. And that's that point right there. Now, domain. So the domain is like how far left and how far right. Which x values does this graph span? The furthest it goes to the left, there is at the x value of negative 2. The furthest it spans to the right is right there, which is x value of 4. So my graph lives in between those two values. There you go. Range, how high, how low. My lowest point is negative 4. And my max point is at y equals 8. So my graph lives in between negative 4 and 8. All right, this guy right here is a little bit different because it's just a flat line. So let's figure out slope. So to do slope, you find 2 points and travel. So if I'm traveling between this guy here and this guy here, what's my rise? Well, nothing. I don't have to rise at all. So my rise is 0 and my run is 1 to the right. So positive 1. Well, 0 over 1 is just 0. Okay, so the slope of a flat line is always 0. Think of if you're ever on a treadmill. If you're on a treadmill for phys ed and your incline is set to 0, you're just walking on flat ground. That's how I remember it. So flat ground, 0 slope. All right, x-intercept. Where does it cross the x-axis at? It never does. It never crosses the x-axis. Y-intercept, where does it cross the y-intercept at? Right there. That is at a value of y is negative 2, so x is 0. All right, domain. Now we see arrows on either end. So if I'm asking you how far left and how far right does this graph travel, we don't know. We don't know where it starts on the left. We don't know where it ends on the right. When that happens, that's a case of this funky thing right there. That means x is an element of real numbers, aka x is touching everything. Range. How high, how low? Interesting. It's at negative 2. In terms of my y-axis right here, we'd only know that it's right through negative 2. It doesn't go higher than negative 2. It doesn't go lower than negative 2. So you just say your range is y is always equal to negative 2, no matter what happens. All right. This one, I chose kind of the opposite. Now it's a vertical line. All right, so if I'm talking about slope and you want to choose 2 points to travel between, you choose any 2 points you want. I'll choose a couple points apart, and that's fine. Now, what's my rise? If I travel upwards, that's 1, 2, 3. So I rose 3, that's a positive 3. And then what's my run? I don't have to run. I don't have to travel left or right. I got to the next point just by rising 3. So my run, you guys, is 0. Now, if you took your calculator and went 3 divided by 0, you would get error. And so we call this slope undefined. Okay? Kind of like it's impossible. Imagine the treadmill analogy again. If you were on a treadmill and Mr. Colzine said, okay, put your slope to look like that. Well, you'd be walking completely vertically. That's impossible. You'd fall off. Only Spider-Man can do that, right? So we call it an undefined slope when it's a vertical line. All right, x-intercept, where does it cross the x-axis at? It crosses right there. That is at, whoops, x is a value of 3, y is 0. For y-intercept, this is the opposite scenario of the example we just did. It does not cross the y-intercept at all. Domain. How far left and how far right? Well, it's literally only at 3. It's stuck at 3 for my x values. Range. How high, how low? Because of the arrows, we don't know how high or how low it goes. So this is the case where y is an element of real numbers. Okay, we're flying here, almost done. Okay, so slope, pick the 2 points. If you look closely, I gave you 2 points right there, colored in a little bit. We're going to travel between those 2. Now remember, you always have an option. You can travel down and to the right if you want to start here, or you can travel up and to the left if you want to start there. Doesn't matter. I'm going to go down to the left or down to the right. So I go down 1, 2, 3. So down, remember, means negative. And then 1, 2, 3, 4 to the right. And 4 to the right is just positive 4. That's fine. So my slope then, my rise is actually a negative 3 over 4. You can't reduce that, done. All right, x-intercept, where does it cross the x-axis at? Right there, that's at a value of 4. Y-intercept, where does it cross the y-axis at? It crosses there at positive 3. Done. Domain, I have arrows on both ends, so I have no idea how far left or how far right it goes. That's that guy. Range, same thing. I have no idea how high or how low it goes. It goes on forever. All right. Now I wanted to include this example here, these two, because they're a little bit different if you look at the units. Okay, so for this graph here, you'll see that the x-axis is in time, minutes, and it jumps by 30 every time, and that's really important, okay? So if I'm asking you to find slope, it's rise over run, you pick your 2 points. Now, look closely at these points. I'm going to zoom in. There's actually only a select few points I want you to use. I would want you to use this one and this one only. And if we were in class, I'd say why? And hopefully someone would realize that all of the other points aren't exact. You see what I mean? They're not crossing an intersection. I call this an intersection where the 2 grid lines cross. So none of these points right here are crossing intersections, but that one is, and that one is. Those are called perfect points. That's what I call them anyway. So I'm always going to choose to hop between 2 perfect points because I know I'm never going to have to estimate my jumps. So when I'm doing my rise, I'm going to rise 1, 2, 3, but I didn't actually rise 3. You guys, I rose 15. Look closely, you started at 15, right? And you rose up to 30. So now we have to really pay attention to what the units are. In all the other examples, the unit was just 1. So if we rose 3, we know it was 3 units. But here, rising 3 actually means rising 15. And then I'm going 1, 2, 3, 4, 5 to the right. But that's actually, if you look down here, I traveled from 0 all the way over to 150. So 15 up, 150 over, and they're both positive. So 15 over 150, reduce that to 1 over 10. Okay, always reduce if possible. I just divided each one by 15. All right, x-intercept, where does it cross the x-axis at? It crosses it, we don't know, right? Because it would go on forever that way. We don't really know where it crosses the x-axis at. We can't visually see it, so we don't know. Y-intercept, where's across the y-axis at? We see it crosses right there at y is 15, so 0, 15 is my y-intercept. All right, domain, how far left, how far right on the x-axis. This is my furthest left point, and that's at an x value of 0. And that's my furthest right point, and that's at an x value of 180. X lives between those two values. Range, how high, how low. So my lowest y value on the y-axis there is 15. And my highest y value is that guy. We have to estimate. So it's in between 30 and 35. I'm going to say that's about 33. Y lives in between those two values. Okay, last one. There's just points here. Okay. So when we're doing slope, you still travel between the 2 points. That's fine. I go 1 up, 1 over, but my slope is not 1 over 1 because look at the units. When I go 1 up, when I rise 1 unit, that's actually 50. So I'm going from 50 to 100. Then when I run to the right, it's not just 1, it's actually a gap of 30, from 30 to 60. So my slope is actually 5 over 3 if I reduce. Now my x-intercept, unknown. My y-intercept, unknown. My domain, because, right, it's unknown because we don't actually see the line crossing anything. My domain, now if you remember from last lesson, I did an example like this where it was just dots. So for domain, when it's just dots, just list the values. So my x values are 30, 60, and 150. Done. And range, same thing. I'm going to do the y values for those points. So the y values are, the first dot there is at a y value of 50. The second dot, this one here, is at a y value of 100. And the third dot up there is at a y value of 250. Okay, that was a bit of a long lesson, but hopefully it helped you with domain and range a little bit if you were struggling with it from yesterday. And then simply enough, slope is rise over run. Remember this tidbit right here. If you're traveling, if you're doing rise over run, going down or going to the left means you throw a negative in front, okay? And then x-intercept and y-intercept simply are where the graph crosses those axes at. So there's an assignment here. It's 2 parts. There's an assignment, a worksheet, as well as a couple questions from the textbook, okay? As always, email me with questions. Good luck.